This next exercise is going to combine all sorts of different things together, okay, maps and sets. So it's going to be a good workout and a good illustration of how we can use those Java collections to test like duplicacy in a list and things of that nature. So the whole idea here is that we want to actually read numbers from the user until the user enters 0. So that's a sentinel control loop, right? So we are going to start by implementing that feature because this is simple, and this is going to make us get the backbone pretty much of our program, okay, the main loop structure. So I need a scanner to read from the user, that's for sure. I'm going to make an infinite loop here, right? An infinite loop, but you're going to see that it's not going to run infinitely. As a matter of fact, I'm going to write here the condition for exiting. If the number provided by the user is 0, okay, then break out of the loop. All right, so that means that now I would like to probably read that number. So let's prompt the user, println, enter an int, okay, and then I need to read that int. So int number equal in dot next int, and there we go. So I read an int, okay, I'm going to repeat reading an int, testing if it's 0. If it's 0, I'm done, so that's my sentinel. And if it's not 0, then let's just test that everything is working by doing a println on that number. All right, so we have something basic, small, that we can run, that we can test, and we are going to do just that. So let's say that I enter 42. Okay, it tells me 42, 23, 99, and then the magic 0, and there we go, I get out of the code. So one feature down from the requirement. Let's look for the next thing we can actually implement that's small, simple, and that's going to be helpful. Well, at some point we're going to have to store in a data structure, so something like a map, okay, a correspondence between all the numbers that we have seen and their number of occurrence, which is how many times we have seen them. So this is typically, you know, the job for a map, right? You have a key, so the key is going to be the keys are going to be all the number that were entered, and then the value for those keys is going to be how many times we have seen them entered. So let's start working on this aspect of the code and this data structure for the code, okay? So I need a map, so I'm going to use a tree map implementation of the map set. It's a map between an integer, so I cannot use int here, okay? I have to use the class version of an int, which is the class integer. And I'm going to just originally call this my tree map, my map, okay? And then I'm going to say it's a new tree map of, and here I could repeat integer comma integer, but I can also use a shortcut notation known as the diamond operator, so I'm going to do that this time, because there's a little bit more to write. So I have a tree map named appropriately map here. And what I'm going to do is, if you give me a number that is not my sentinel, instead of just displaying it on the screen, then I'm going to use this map to keep track of how many times it has occurred. So first step, well, let's see if we have actually this number in the map. So I'm going to use a variable key that I'm going to define and assign in a second, okay? So I'm going to say, all right, if this is in the map already, then I need to increase by 1 the value for that key, else I need to actually insert that key with a number of occurrence that is 1. This is the first time I've encountered. So that still doesn't tell me what key is. Well, key, because I need to use a key that is an integer and not an int, I'm simply going to, you know, and I could do that simpler with using autoboxing, etc., but I'm going to be quite explicit for this time. I'm creating an integer object that wraps around the number int value that was given to me, and I call that my key. Okay, so I have already like here a little bit of of logistic going on. Let's see if I can even compile this first, okay? So if I run it, it's not going to do much more. Actually, it's not going to do anything more. Okay, let's see. There we go, but it's still working. So I'm making sure I didn't break my code, okay? It's kind of like just making sure that I didn't break previous feature that we're working by adding some code or working on my next feature. So now for the fun part. Let's start with the easy one. If I do not have that key in the map yet, well, I want to add it. So I want to say, I want to add an entry in my map that is that key, so the number that I just encountered for the first time, and the value, which is the number of occurrences, I'm going to put an integer object equal to the int value 1. So I encountered it for the first time. Okay, so this should be able to tell me already, well, you encountered at least one time, each of those numbers. So that's good. But I want to be able also to do something when the key is already in the map. And that something means, taking the value actually associated to that key and then incrementing it and then putting back into the map, an entry for that key that has this incremented value. So it's kind of a 3-step process. So let's start by extracting that value. And we're going to extract it as an int, okay? Just easier to manipulate and increment. So integer conversion as an integer of what I'm going to get out of my map. Dot get key, and that conversion actually is a little bit superfluous, but so I'm getting the key converting to integer, and then I'm going to say give me the int value, which is a method of the integer class, so that I can assign it to my variable value. Now I can just do ++ on value, increment it, and then I can say, well, now that I have my incremented value for that key, let me put it back, but instead of just putting back value, which is an int, and relying on autoboxing, I'm going to be explicit again and say, okay, I want to put that value, but integer, but I want to put it as an integer object. So again, a little bit heavier syntax that we could write, but it's going to work just the same. So let's see what we have. So I'm not capable actually to test yet if the code is actually counting the right way, but I can at least enter a different value and then make sure that I can still exit my code. But now I have this. So this is the end of my while loop here. Now I have this this map, and inside this map I have a bunch of keys and values. So I need to do something with those, right? That's the whole point of this exercise. So let's see how we're going to start. We're going to start by, because the requirement tells us you need to display to me the number that has occurred the most, the number or numbers, okay? So it's not just about like going over the map, iterating over the map, and finding the number with the highest value, the key with the highest value, and display that one. Because we might have several keys that are different, but that have the same value that just happens to be the maximum number of occurrence. So first we need to figure out what is this max, okay, this max value of occurrence. So we don't focus on the keys right now, we focus on the value. So we can use from the collection class a static method called max. That's going to return to us the max of a collection of values, okay? And in this case, we want to extract from the map all of its values as a list, okay? So we are getting as a list all the values in the map. We're looking for the highest value. So we are not messing at all with the key. So let's display that for now. System.out.println, okay? Max equals, so this is the max number of occurrences without caring about what number or numbers occurred this maximum number of time. So let's take a look here, compile, run. So if I do my classic test that I've been doing up to now, okay, well, each number occurred only one time, so it's not going to be a great test. So I'm going to add another test. I'm going to do 23, 42, 23, 99, 23, and then 0. And okay, it seems to have caught up on the fact that 23 occurred 3 times. But I have not isolated yet, the key that was occurring the maximum amount of time. So I'm going to work on that next. The key, or keys actually, I should say. So the next step, I'm going to use a set of integer that I'm going to call keys. And as you can guess, I'm going to store inside that set pretty much the set of all the keys used in my map. And I'm going to do that because I want to look at every key in my map, okay? And I want to look at pretty much how many times it iterated and check if it iterated that max number of times that we already identified. So I'm going to need an iterator. So I'm going to call my iterator it, and it's going to be actually an iterator of integer, okay, it. And since I just got a set here with all the key values, so all the number that I encountered once each, and I'm going to just get the iterator from that, and then I can use my iterator in a while loop, it as next, all right, and what am I going to do? So I need to get the key, so my key should be an integer key equals it.next. Okay, so I'm iterating over a list of key values, right? So I want to get them one by one. So every number that I have typed as a keyboard is going to be a key in that map, okay? And I put the set of all the keys in a set of integer, and now I iterate over that set. So I'm going to consider every different unique number that I've entered in the keyboard. That's what this loop is doing, okay? Now I would be interested in getting the value for that specific key. So I can go ahead and pull the value from the map by doing a map dot, cannot type today, again, get, all right, and there's a key here, all right. So I'm iterating over all possible keys, all right, and then every time I'm going back to the map, getting the value for that key. And then what? Well, if that value, and I'm manipulating integer object here, so I have to use dot equals instead of just the equal operator. If that value equals the max, well, then I found one of them, right? I found one of those keys that occurred the maximum number of times. So system.out.println number, and then I'm going to specify here the key occurred the most often. And I'm going to put into parentheses here max, and then times. Looks good. Okay, so I just as a reminder of what the max value was, and I can stop displaying it here. I know that that part works already. Okay, so every time I have a number that occurred that max number of times, I'm going to display it. Okay, so that's why we had to do all of this. We are not just looking for the first key, you know, in that map that occurred the maximum number of time, or assuming there's only one. Now we are assuming that there may be several, and we want them all. So let's go back. So my test, assuming that I can compile this, yep, there we go. So my first test was just to make sure I could exit, you know, this program, this loop. So it was something like, if I remember correctly, I should write this down. You should write it down too. 23, 42, 99, and then 0. So if I run this test, it tells me that everything occurred one time. So everything occurred the most often, because the most often, the highest number of occurrence is 1. Well, that's acceptable. Then I use another test that was something like, so let me run this again, 23, and then 42, and then 23, and then 99, and then 23. Well, in this case, 23 is clearly the one that occurs the most times. It occurs 3 times, so yes, we are good. Okay, this is working well so far. Let's run it again, and I'm going to add another test trying to figure out what happens if not all my numbers are winners and not only one of them is winner, but I have 2 of them that are winner. So for example, if I do something like 23, 42, 99, 23, 42, 300, 23, 42, you see the pattern, right? 900, So I have 23 and 42 that each occurred 3 times, and then I have a bunch of other numbers. Let's see what it says. 23 occurred 3 times, 42 occurred 3 times, and the other number just occurred 1 time, so we do not display them. So we have here a very neat little, and I cannot actually make it so that the whole thing shows in one screen, but I'm going to scroll slowly for those of you who are jumping at the end of the video. We have a neat little example here of how we can use sets, we can use iterators, we can use maps, all in conjunction to actually implement in a very nice way this kind of feature that otherwise, if we wanted to do everything by hand, well, we would have to re-implement those collections by ourselves. And doing so would probably open the door to many, many bugs. So instead, we use the Java collection framework for what it's good at, and this is what we get as a result.